Excellent. Wow, that's the perfect one. I feel as though I'm could be a rock star on the stage with all of these kind of things, but I'm certainly not. I'm just a technical guy like one of you. Well, first, before I start talking about my presentation, I just want to highlight how awesome it is to be here in Cardiff again. I was at actually the last serverless days in 2020. It was in February. It was in the other shed. Luckily, I worked out that the other depot had moved because I would have wandered into the wrong place, the wrong warehouse this morning if I hadn't. But I remember it was February and it was absolutely freezing, and everyone had these massive coats on, and we were all trying to keep warm and sort of be community together to stay warm. So it's really nice that it's. We're obviously must be more warm-hearted this year to warm up the place. So yeah, to be back here 3 years later is super cool. And another thing I want to highlight is that as this is a community event, I really want to encourage everybody here to actually talk to each other. And I know that sounds maybe heresy at an IT conference, like how on earth are you going to get nerds to talk to each other? But the cool thing is yes, we've got sponsors and AWS, and we've got other cloud providers, people here, but actually the knowledge that you're going to gain from each other by just finding somebody having a coffee or having lunch or something is actually invaluable. And I know there are a lot of organizations over here who are doing some awesome stuff, particularly on AWS, and really I would suggest you reach across to somebody else and learn from each other, because that is super awesome, and that's also the power of community. But today I'm talking about Serverlesspresso, and just quick hands up, the lights over here. Has anybody had a coffee from Serverlesspresso this morning? Good number of people, so hopefully they're the ones who are going to be staying awake. If my presentation, that was basically the plan. If I can feed you coffee in the morning and then you're going to stay awake during my presentation. But yeah, my name's Julian Wood. I'm a developer advocate within the serverless team within AWS. That means I've actually got a really cool job of being able to talk about technologies. But also another really cool part of my job is basically taking the feedback from days like today and feeding it back to the product teams. Now, normally that's sort of done in a bit of an asynchronous way. And to be honest, I'm slightly nervous because I've just had to come on stage after the general manager of workflows. So the general manager of EventBridge, and then I've got to talk after him and make sure I don't make any mistakes and say anything wrong about his service. So please bear with me, Usman. But the cool thing is we love the feedback. So please tell me anything to do with serverless on AWS or general AWS. Let me know, feedback, comments, questions, and we literally feed that back directly to the product managers. And as Usman showed on his slide, all of that innovation and all of those new features and services that come out is literally 90% due to your feedback of things you would like. So things you need, things you want, let me know. I'd be happy to feed it back. Usman also did spot this morning. He said, "Are you wearing a rugby jersey? Are you a big sort of rugby fan?" I was like, "Oh, no, I do enjoy a bit of rugby. But you may hear from my accent, I'm actually from South Africa. But very luckily, I know that we're not in the same group in the World Cup. So hopefully there's no animosity over here. Maybe in a few weeks' time, if we do clash somewhere else, there would be. But I don't feel as though I'm starting the talk today already challenging you with your sporting kind of things. So what is Serverlesspresso? Well, hopefully you've seen what it is at the back, but it's basically a coffee ordering app, but built with a serverless architecture. And the whole idea is to show what Usman is talking about, event-driven architectures in real life. Because if people haven't been building event-driven architectures, you may be thinking, well, what does this practically work, and how would I build it? So we've basically put together the Serverlesspresso, and it allows you to place an order on your mobile device, and then scan a QR code on the screen, and you basically do the order on your phone. And then there's a whole sort of back-end component, which is all serverless, all running in AWS, all using our services, and the baristas interact with that to say, there's an espresso come in, there's a macchiato come in, all the different kind of coffee things, and they manage the order, and then once the order is completed, it'll pop up on your phone to say that the order is ready and on a big screen in the background. So there's two sort of concepts of this. There's a whole web component and the back-end component, and they're all using serverless features. So I don't want to keep turning around and staring at the slide to see what I'm looking at, so I'm just making an adjustment. So there are three front-end applications. There's the display web app, and if you got a coffee this morning, you scan the QR code, and that shows the sort of the channels of which coffees are ready and which coffees are still being processed. There is then a TV display app, and the display web app is not on the TV, that's on your phone. And then there's a TV display app which has the QR code, and that's where you scan it and just keeps updating what's going on. And then there's a whole separate app which a barista has, and that's actually on a tablet behind the coffee stand. And this is where the baristas manage the orders, and they can, decide to make 3 espressos at a time, and they just, take it from one sort of lane, and that's going to then update the front end with what's going on. And so here we've got the display app, and it's actually got a barcode which changes every 5 minutes. And I'm going to explain why the barcode is going to be used. Not a barcode, a QR code every 5 minutes. And this is going to receive the order updates, and it listens for whether the store is actually open or store is going to be closed, and just is the front end for the store. The ordering app allows it, and this is what you do when you have your code, and you then scan the barcode, and you get the order, and it's going to validate then the ticket. Validate the token. And then it's going to load the current menu, and that's fully customizable, actually just stored in DynamoDB. And this can change, and then you're going to be able to place your order, and that's going to tell you that your order number is done, and then while your order is being made, the front end's going to know about that. And then as soon as your order is complete, the front end's also going to know about that. So that's a cool thing. You could actually be wandering around the whole venue, and you'll get the notification on the front end web app to say your coffee is ready, and you can rush back to the back to get your warm coffee without having to stand in the queue. And then here's the barista app I was talking about. It shows the incoming orders, and it allows the baristas to interact with that. They can, when customers are ready to pick up, they can also cancel orders. If something happens or a customer cancels it, or they can, they've run out of milk or something, they can cancel the orders. And also, it prints the tickets. So there's actually a local printing service, a local printer which prints the tickets, which has the order number. And so when the coffee appears on the table, there's a number with it, and so hopefully people aren't stealing each other's coffees. And so here's just a bit of a demo of what it looks like at a, of course the video is not playing because, anyway, technical things, what you can do. Well, the demo is at the back, so you can also go and use it and do a coffee. I'm sure you can appreciate what that's going to be using. So a whole bunch of different AWS services that are being used, all of the serverless ones, things like Amplify Console. Amplify Console runs the front end. It's actually quite a sort of clever wrapper where it stores the static assets in S3. S3 is, I don't know, probably one of the world's biggest web hosting services. It's incredible that you can just store files directly on S3 and make them available on the internet as a web page. And Amplify wraps that really nicely and has additional authentication options and additional front-end kind of stuff. You've got API Gateway, which is the front end in terms of an API, managed API service. DynamoDB for a NoSQL database service for storing things. And then what Usman was talking about, EventBridge and Step Functions, which does a lot of the back-end workflows, Lambda functions for running some additional code, and then this sort of weirdly named service called AWS IoT Core, which is actually for giving notifications to the front end. And I'm going to get on that a little bit later. So let's look at the high-level architecture. So this looks like a whole, bit of a complex diagram, but basically this is a way of building serverless architectures that you can tease out a lot of things out of your code, and you can show them in sort of different services. So from the left-hand side, we have the front end. So the 3 front ends are hosted on Amazon S3, and the access layer is used by API Gateway, and that's going to provide access to the business logic and also the data layer. Then the lifeblood of this whole event-driven architecture application are the events, and EventBridge is the serverless event bus, which is going to deliver the multiple messages between the different microservices. The rules are then routed to the various downstream services, and then there's a whole orchestration system which is going to be using step functions, and this acts as the workflow to manage the whole order process, and then real-time information is delivered to the front ends using AWS IoT Core. So just having a look at how some of the services work. And when we were developing this, we were sort of defining the workflow. And as all good software architects and developers, before doing anything, it was sort of a brain idea of, well, what did this application actually need to do? And so, we thought, the store may be closed and open, so we obviously need to do a check if the store is open. We need to check that the barista's actually got capabilities, because the cloud can be infinitely scalable, but our lovely baristas, as clever and fast as they are, they can't make unlimited coffees in a minute. So we need to check that they can actually handle the coffee order. We've got to wait for the order. We then got to generate an order number. We've got to wait for the barista to make the drink. They need to be able to cancel that and do it as well. And also, what happens if the customer cancels it? All these kind of things go through the head of building the application. And this is obviously done before writing too much code, and that's how we're going to do it. Then we're thinking, okay, so we've got all these ideas. And we took some of these steps, and we started sort of building out Lambda functions to do the actual work. And using pseudocode to sort of get a feel of maybe how many functions we were going to do, how would this microservice be set out, and what the individual functions within the actual Lambda service would be. And just the pseudocode side, on the left-hand side, you've got some nested if statements for logic branches. And on the right-hand side, there's some pseudocode for starting an EventBridge schedule rule every minute to maybe kick off the orders. But as we were doing this, we sort of realized that this was actually turning into quite a fragile approach. And we realized, well, what we're actually doing is building a state machine. So state machine and workflows is all about nested if statements and branching logic and all this kind of thing. And even though we'd come up with our idea of how the coffee ordering system would work in our heads, and we were starting to think about pseudocode and then writing a Lambda function to do with it, a lot of this stuff is really boilerplate code, and it's not going to be very extensible. And so, if things were going to change and we wanted to, the wait time, there was a wait time, it was presented before, was going to be 90 seconds instead of 5 minutes. Oh, how that's going to impact our function. Would we store that in an environment variable? And how would this going to work for sort of thousands and thousands and thousands of orders? So the realization was, well, actually, if we moved a whole lot of this code into step functions, which is going to be a resilient workflow automation, this could make things far better. We'd be able to reduce our reliance on writing a whole bunch of code that we need to test. And we've got error handling, we've got a whole bunch of cool AWS service integrations, and an execution history that we'll be able to look at for every single order. And obviously, as Usman talked about, well, that initial mind mapping we were doing of actually building the serverless architecture, well, we can actually now build that on a visual designer. And this is such an important difference. When the first approach was we were thinking about it in our head and we started writing pseudocode. And that pseudocode is gets a bit complicated and gets a bit clunky. But actually, with our workflow, we could visually build our idea for the application. And this is not only in the IT sphere. If you're working with a business analyst at your company, and they've got an idea of how an order processing for a finance or a driver's license or a visa application, all these kind of things. A business person's got an idea of the workflow that they're going to do, and you can actually partner with them and build this out on a canvas, which makes far more visual sense than looking through some JSON code or YAML code or a whole bunch of text-based information. So designing it visually with Workflow Studio was really made it much easier. And so we built this workflow on the right-hand side, which ensures, first of all, the store is open. Allows the customer 5 minutes to order the drink. Allows the baristas 15 minutes before it's automatically cancelled. And then obviously we've still got some Lambda function code that is going to be in here, but the Lambda function code is limited to the custom business logic. It's not having to handle all of these decision trees and all of these timeouts and these wait statuses. This is all run as part of a managed service with step functions. And so, as you can see on the front end, the whole sort of order system goes with the QR code on the app, and you can see on the right-hand side, as the workflow goes on the left-hand side on your mobile phone, the right-hand side is going to go through all the different parts of the step function. So you can see this is our sort of security mechanism that you get a QR code which gets sent via SMS and allows you to log in, and you can see the step function is then progressed, and it's going to validate your ticket. You then have got time as the orderer to now choose which coffee you're going to order. Are you going to have any pumps or different? This is obviously done in America. People want caramel and lots of different flavorings for their coffee, not just plain coffee. The order goes in the queue, and then there's another pause state where the baristas are going to have the time to then make the coffee. And we want all of this to stop and have some way for the baristas to decide, yes, the coffee is ready, and they're going to make the coffee. And then once the coffee is ready, they can interact with the back-end system and carry on that workflow. So there's sort of two different parts of thinking of this whole workflow is going to be automatic, but it needs to pause for human interaction. It needs to pause for someone to order coffee, and needs to pause for a barista to make it. So, and then afterwards, there's a whole, afterwards you can actually look at the visual journey of your whole order of the coffee, and this is obviously super old because you can see it's a Twitter logo rather than an X logo, for the clever people spotting that. But that shows how the workflow on the front end maps with the workflow on the back end. So in version 1 of the workflow, we now have a basic workflow, and it sort of works as a conveyor belt for the drink. And it performs some simple checks, and then it's going to wait at the right points for the customer and the barista to choose a coffee and make the drink, handle those timeouts, and then it's going to emit events as needed. And a single workflow, as this production line, and has this interesting emit and wait pattern. And this is one of the powerful parts about step functions, that you can start a step function state execution, and it just internally it's called wait for task token, and step functions is just going to wait. And a standard step functions workflow can run for up to a year. So literally think of a lot of those automated processes that you may have in your company that need to stop and wait for a human approval, or need to wait for somebody to put a box on a truck, or someone to print a passport, or to create a driver's license. All of those can be built into your workflows with a bit of human interaction or some other machine reaction, which can then talk back to step functions and say, you know what, I'm done with now, mind a little bit, you can carry on. So it's a very powerful pattern that this workflow is able to do. And at the various stages in the workflow, events are going to be emitted, which is going to be then sent to EventBridge and allows the rest of your other microservices to react on them. And so here we've just got some different examples where an event is emitted and then Lambda function is going to kick off when that event is emitted and do something else. So we've got a second milestone, and that's also going to then do the task token, which is going to wait for a set amount of time. So the architecture so far is just a workflow that emits a few events to an EventBridge bus, and there's nothing else. We don't have anything on the front end. So this is where the QR validator service comes in. And initially, we knew that we wanted a QR code scan to start the ordering process. And originally, we looked at a static code where we thought, yeah, somebody's going to post that on Facebook or LinkedIn or something, and we're literally going to get 1,000 coffee orders, and that's going to completely mess up the system. The barista's going to go like mad with seeing 1,000 coffees in. How can we protect that? So we came up with this actually cool idea of having a QR code that's going to generate every 5 minutes, and it's going to have a number of tokens that's available in this QR code. And so depending on how many baristas we've got, we can, in a way, manage the throughput of the orders that is going to go through the system. And so the QR code microservice validator was born as a separate microservice to be able to do that. And that's going to generate a QR code which is going to be valid for 5 minutes, and it's going to have a certain number of tokens which equals a certain number of coffees in that available time. Now we've got 1 coffee machine today and 2 lovely baristas, but if we had 10 coffee machines and 20 baristas, we could just set that token size to be 10 times as much, and we'd be able to handle many of those coffees. And so the architecture is a REST API with sort of 2 methods, and it's going to emit events. And originally we just used, as you would a developer, Postman for testing, but we quickly started then being able to build the skeleton of the ordering and the display app that would then use the 2 endpoints. So the system uses a token bucket system. The last code is a global system index from DynamoDB with a timestamp, and this is basically, yep, there are going to be 10 available coffees within these 5 minutes, and every time somebody orders a coffee, it's just going to remove 1 token from the bucket, so that's 1 left. And then when somebody does scan the QR code for the 11th one, it's going to validate that and say, sorry, the task token is timed out, there aren't any more coffees available, and on the front-end screen, it's just going to sort of pause the store opening and saying, sorry, the QR code is not available until the next refresh cycle 5 minutes later would be. So that gives the baristas time to make those 10 coffees without them being overwhelmed, and people can sort of mill around and they can wait for the next coffee. And at this point, we sort of have an endpoint that can handle the IDs for the QR codes, and the event can then trigger an order workflow. And now we also need a way to interact with the workload. And if you remember, there's some actions that customers could do. Customers can update their order, or they can cancel their order. A barista needs to be able to complete the order or cancel the order. And then the task tokens that are generated, they've got to be stored somewhere. And then the barista and the web apps also need to be able to get a list of the opened and closed orders when they first start up. And so the Order Manager Service microservice was born. And so we wanted to make this as a separate microservice because it's going to have a distinct job, and that's going to manage the orders and provide this functionality. And again, it's also got a REST endpoint for the user interfaces, and it's going to then consume and emit events to the EventBridge event bus. And so inside, it's actually a standard serverless microservice using what many people will deploy as the bread and butter of it: API Gateway, Lambda, and DynamoDB. And each order, as it goes through the service, is then going to be saved to DynamoDB. And then whenever a state order changes, that's going to kick off another event which other services are going to be able to interact with. And so on version 1 of this, each of the main Lambda functions was handled by the service API Gateway. So, cancel, complete, make, and create an order was basically just update DynamoDB and then resume the step functions. And we used this implementation for quite a while, and then found sort of, as we added more functionality, we realized things were just getting more tightly coupled. It was going to be slower to release, and it was basically adding more complexity for our architecture. And also, it was hard to find and hard to work out given the whole GitHub repo layout we were using. And so what we decided that, as the application was growing, this was just going to get harder to manage. And so in sort of version 1.5, for example, of this Order Manager service, we decided to use something with API Gateway that has direct service integrations. So remove some of that custom Lambda code. So, for example, API Gateway can talk directly to DynamoDB, for example, and it uses VTL, Velocity Template Language. And I'll be the first to say that's not the most intuitive language to use, and it's terrible to test. But it is a sort of industry standard that people do use. but you could actually use VTL. So once we worked out the VTL syntax and we were able to get that, we were able to basically connect API gateway directly to directly to DynamoDB and remove that Lambda function in the middle. And this has got a few benefits. First of all, it's going to reduce costs. We haven't got Lambda functions that are going to run. It's going to reduce some latency because API Gateway is talking directly to Dynamo. And it's going to reduce the code and just have less complexity. And it's actually going to be able to release the scale because we now no longer have a Lambda function in the middle that we, if this was at huge scale, we need to think about how that's going to scale up. And so for write operations that are then, so those are the read operations for getting information, but for write operations that are going to be more complex, where we do need to do some thinking about what this order is going to be, we replace the Lambda function with a step functions workflow. So API Gateway, as I can talk directly to DynamoDB, API Gateway can also talk directly to step functions. And this, the reason for this was going to be easier to debug and manage and track those transitions, and also easier to make changes to the workflow. So at this point, we could have sort of left this design as it is, but we sort of had an interesting idea. Could in fact, the entire CRUD microservice actually be turned into one workflow instead? So instead of having a separate state machine for each CRUD operation, how would we work that if we put that all together? And this was actually a really interesting idea. And we couldn't, so we built version 2. In fact, we replaced the direct integrations from API Gateway to DynamoDB, and we just combined everything into one bigger workflow. And so the first transition decides on the action to take based on the incoming API Gateway requests. So as the API Gateway request comes in, the font isn't so great over here, but we've got a, is the a customer order? Is it to cancel the order? Is it to complete the order or to claim the orders? And those were the sort of 4 different API paths that were coming in. And so we could map those into 4 different ways that you could navigate through the state machine. And all of these use step functions direct integrations to complete their tasks. Step functions, as Usman spoke earlier, has direct SDK integrations. I think it's something like 10 or 12,000 SDK interactions that AWS has. Step functions can do that all amazingly as part of the configuration. No code required. Super happy. And we still need to use a Lambda function. So when we need to do some more complex customer business logic, a Lambda function is going to sit in there absolutely perfectly. But a lot of the other kind of stuff we can take out, and it's going to be easier to use. But now we have a sort of sync versus async kind of issue we need to think about. Usman also talking earlier about the powers of event-driven architectures, and they are amazing. But the thing is also, when we are building synchronous websites, how can we actually return a value from the caller in the same way as you can for a synchronous process? So in this example, the client is going to make a request to service A, and the service A is then going to make a request to service B, and then you obviously need to get service B's response back to the client. Now, in a traditional way, a front end or something would do something with polling. And someone explained this to me when I was learning about this many years ago, as if anybody who's got kids here has a kid in the back of the car, and they say, "Are we there yet?" Yeah, no. "Are we there yet?" No. "Daddy, are we there yet?" No. "Daddy, are we there?" And that probably gets a bit annoying, probably gets a bit on your nerves, but that's the polling mechanism of you asking a service for a request and you waiting for a response. But obviously, if we had to do this in Serverlesspresso, we had this whole tracking kind of thing. It's going to result in so many empty calls. You're just calling something to come back to say no, and it's also going to cause a delay between the front end notification. So another way people can do things is a WebSocket, where you just basically go to your endpoint, please do a thing, and then when the data comes back, it just says, yes, it's ready to do that. And WebSockets are super powerful, love WebSockets, but they can be quite actually complex to set up. And so, in comes to the picture is AWS IoT Core. And I said earlier that it is poorly named because AWS IoT Core, everybody thinks, surely it's got to be my Raspberry Pi devices or my little Roomba robot that's running around the floor. That's what an IoT device is. But actually, your front-end web application browser can also be an IoT device. And IoT Core uses MQTT under the hood, that is the protocol, and it's a managed WebSocket service. And it makes it really easy to use WebSockets in a managed way with a lot of little code. So you can see the flow over here is that the SDK within the front-end JavaScript application makes a subscription to AWS IoT Core, and it's going to then receive the messages published by the backend to the topic. So there's a Lambda function, which is just going to generate a message to AWS IoT Core, and the front-end subscribes to that and receives those messages. And the messages can be categorized in topics. So for example, in Serverlesspresso, we've got two different ways that topics need to be categorized. One is for everybody. So if the store is open or the store is closed, well, all your mobile apps need to know that, and the display app needs to know that. But if your order is ready, it's only your order that the notification that needs to go to your mobile device. And so WebSockets and IoT Core can scale up to handle this with this amazing fan-out functionality that is, I don't even know what the figures are for the fan-out amount, but it is crazy amounts, so it's really easy to use. And the most important cool thing about AWS IoT Core is the little amount of code you actually need to do it. So this is literally the front-end code. It's going to connect the MQTT client, handle any errors, and then receive a payload. And that's kind of the code that you're going to do on the front end. And on the back end for the Lambda function, I think it's literally 20 lines of code to send that. You pick a topic, send it to IoT Core, and it's going to appear. What is cool about this as a managed WebSocket service is that if the network connection drops, when it reconnects again, it's just going to be able to connect and carry on with your conversation. So this is super powerful to be able to have this, which we wrapped up in a publisher microservice, that any of these events, anything we need to send to the front end, we can have a publisher microservice that can send it to AWS IoT Core, and that's going to be sent to your front-end device. So long story short of all of that is, AWS IoT Core is super helpful for building synchronous applications where you need an asynchronous workflow that works in the back end that also needs to give updates into the front end. And so this can be a front-end web app, which is really easy to code with that. And yeah, it's actually just so easy. When I learned about how this all works, I was just astounded how easy it was to have this responsive web apps where you can have the synchronous part up in the front and then a whole asynchronous event-driven architecture in the background, but the two work seamlessly together. So obviously, we probably need to combine sort of multiple approaches for the front-end application because there are going to be notifications and there are going to be APIs. So Serverlesspresso, when it starts up, it makes a REST API call via API gateway to a Lambda function in DynamoDB, API gateway directly to DynamoDB, and that's going to get, is the store open, and it's going to get the menu, so it's got the coffees. And the menu is fully customizable, so we can add anything, but that's going to happen on the startup. And then it needs to subscribe to the topics to say, hello, Mr. and Mrs. IoT Core, I need information on, here's who I am, so you can get in contact. And then all the orders are processed asynchronously via the step functions backend process, which is going to then communicate back to the front end. But all of this needs coordination between these different microservices. So we've covered step functions and the routing of how the whole order management service goes. But the cool thing about this whole service is these individual microservices then communicate between each other using the power of events. And an event, as many people may know when you're talking about event-driven architectures, is literally just a bit of JSON. So literally a bit of text that gets passed between certain services, and in some detail is your custom code, your custom JSON that you can write anything. And you could have an order number, you could have a name, you could have a stock price, you could have literally anything. And it's just, there's an envelope with that, which is metadata, and then the detailed information has anything customizable for your events. As Usman spoke about earlier, producers produce events, an event router in the middle, like EventBridge, can then pass those events onto any number of other downstream consumers. And so Serverlesspresso has, I think, 15 different events. So a whole bunch of different events that it's going to emit, which we can then listen to. And so each of the service publishes events onto the event bus, and then some of those events are going to kick off a workflow, some of those events are going to update the front end, and some of the events are just going to be picked up by other microservices that are then going to react. And the cool thing is to actually add to the service is really easy. Because they're events and it's decoupled, we can add to this workflow and event system really easily. So we actually built a whole plugin architecture for this called Serverlesspresso extensions. And this allows other people to be able to create separate extensions for EventBridge, or for separate extensions for Serverlesspresso, where they don't have to mess with the original application. Because we all know how annoying that is when you have a whole application and somebody comes up with a great idea for new functionality, and then you're like, oh, that's going to be hard. We're going to now need to give you access to another database. We're then going to have a synchronous API call to give you access on. All that coupling with synchronicity that is going to be a problem. So Serverlesspresso extensions just listen to rules, does this whole kind of thing, and then just emits a rule back onto the event bus, which another service can react on. And so we have the core application, and yeah, as I mentioned, the different extensions. We've got extension 1 and extension 2 here. They're just listening for events, and they can pick any of those 15 Serverlesspresso events and do something. And when they finish, they can emit their own events, and then other workflows can talk to that. So examples we've got, we did it's not actually live on the system we're running at the back, but we do have an average wait time. So you know how long your coffee is going to take before the next coffee is available, so you can walk around or go to the bathroom. There's another one where we were doing business metrics, so we created an observability extension, which we used SQS and CloudWatch to be able to create dashboards. And on the right-hand side, we actually displayed this at reInvent, so we could see the number of espressos and the number of macchiatos and flat whites, and sort of a useful way to show how you can build business applications. But you're also thinking there, no, this all looks lovely, but this is going to cost an absolute fortune running a coffee system in the cloud. Well, there's the total cost. And if you notice, SNS is the most expensive part of it. Everyone says to me, what's SNS doing with this whole thing? That's actually the SMS code notifications that is literally, what is that, $7.98. So $7.98 is because we've obviously got to pay SMS providers to handle, and this is for 960 to 1,000 coffees a day. That's what costs us all the money, is sending out the SMS messages. Now, if you were building an event-driven architecture in your organization, you probably don't need to use SMS as your verification. You could use something else like email or something and drop that down to 0. But look at the rest of it. The rest of it costs under 50 cents a day for 1,000 coffees, and that's when you even out of the free tier. When you're within the free tier, it is literally free. So the whole thing could run today for 1,000 coffees with all the state messaging transitions, listening to all the EventBridge rules, the Lambda functions that are going to fire off, and it's going to be under 50 cents a day. So I think that is super good value and shows the power of running serverless architectures. It's going to be 50 cents today, but if there's no event tomorrow, it's going to cost literally absolutely 0. So this is another part of the whole serverless architecture, is you only pay for what you use. While we're busy doing coffees today, you're going to pay a little bit of money and then nothing tomorrow. So thanks so much for listening to the talk. I know I had to squash a whole bunch of information in 30 minutes, but luckily Michael Hume and I are here all day, so we'll be able, at the back, we'd love to hear your questions and comments about Serverlesspresso. First of all, come and get a free coffee. Happy to talk about how event-driven architectures work, about step functions, Lambda, anything to do with serverless on AWS. But yeah, thanks so much. I appreciate your time. My contact details are up there. It's really nice to see everybody here today. And yeah, enjoy the rest of your day. I've seen some of the talks coming up before, and they are awesome. So looking forward to also learning more about serverless. Thank you very much.